similar triangles. So just as we have said the other time that similar triangles have the same angles, but the length of side are different. So just pencil it down now formally. Similar triangles have the same angles. You have the same angles, but the length of sides are different. So I want you to take note of that. That's why I'm underlining it. So they will have the same angle, but the length of side will be different. And that is why I said in the opening preamble that such will happen when you have an enlargement or a compression carried out. So it's different from congruency. In terms of congruency, then you can look at translation, you can look at reflection, you can look at rotation for that. But when there is enlargement or there is compression, then we say that it's going to produce similarity. And the similarity is going to be in terms of having the same angle, the different size of their length. So I'll give this to illustrate that now. Suppose you have this triangle A, B, and C. And this is angle A here. I'm going to use this symbol to tell you that the angles are different from each other. So that's one. I'm just trying to show that one is bigger than the other. So this is P, Q, and R. So you can see that angle R is the same thing as angle C. Angle Q is the same thing as angle B. And angle P is the same thing as angle A. So in terms of angle, they have the same value. Do you understand that now?
Yes, sir.
So in this context now, you say that triangle ABC is similar to triangle PQR if the following conditions are hold. If one, AB ratio PQ equals BC ratio QR equals AC ratio PR. And also, angle ABC is equal to PQR, just as I mentioned the other time. This angle here is equal to this angle here. Angle BAC, that's angle A now, equals QPR. And ACB equals PRQ. Is that clear?
Yes, sir.
Okay. Now, hope you are writing that.
Yes, sir.
Okay. However, two triangles are similar if they satisfy any one of the following. Any one of the following conditions. So those conditions are what you now use to answer question. Number one, all angles in the first are the same as in the second. All angles in the first are the same as in the second. For instance, I have this triangle. I have another one. If this is Z, this will be Z. Or Z can be any other place. If this is Y, this can be Y. If this is X, this is X. Is that clear? All angles are the same. So you have triangle A and triangle B to be similar because all angles in A are the same as that of B. Does that make sense to you?
Yes, sir.
So when you're done writing that, let me know.
I'm done, sir.
Okay. So the second condition, number 2, is that all the sides in the first, all the sides in the first are in the same ratio as the other. For instance, the first triangle has A, B, C sides. The second triangle now has 2A, 2C, and 2B sides. You get that now? So if you look at it, let me say this is P, Q, R. And let me say this is S, T, U. So you can see that if I say PQ ratio ST, PQ ratio ST, that would be A over 2A, and that's 1 over 2. Can you see that?
Yes, sir.
Okay. Now, the ratio of side PQ to ST is 1 over 2. Now, if they are similar, if I take the ratio of side QR to side TU, I must also get 1 over 2. So that will be C over 2C. This cancels this, we have 1 over 2. Also, PR ratio SU, B over 2B. This cancels this, you have 1 over 2. So you can see that the ratio of the side of triangle PQR to STU, they are the same throughout. Hence, you say that the triangles are similar. So that's what the second condition is saying, that all the sides in the first are in the same ratio as the second or as the other. Hope that makes sense to you.
Yes, sir.
All right, quickly write that before we now see the third condition.
Done.
Okay. So the third condition is two sides on one are in the same ratio as the other. Also, the angle between the two known sides is the same as the other. So this is what that is saying. Let me put the diagram here. You have this triangle. This side is known as side A. This side is known as side B. Then the angle between side A and side B is known as S. So we are now saying that for the second triangle, This side is now known to be 2B. This side is known to be 2A. This angle will still remain X. Is that clear? That's what that third condition is saying. Two sides of one are in the same ratio as the other. So if you look at the first triangle, let's say this is triangle A, B, C, and this is triangle P, Q, R. So ratio of side A to ratio of side PQ, 1/2. Ratio of side AC to ratio of side PQ is also 1/2. So it satisfies the same ratio. So since the two known sides satisfy the same ratio, then the angle between the two known sides must be the same, XX. That's what that theorem is saying, or that rule. So pencil that down quickly. So when you're done writing that, let me know. When you're through writing that, let me know.
Okay, I'm almost done, sir.
All right.
On three, sir.
All right. Now let's see another important tool that we'll be using to solve problem. I call that scale factor. Scale factor. Let's suppose we have triangle A and triangle B to be similar. So if A is similar to B, if A is similar to B, then scale factor equals length of B over length of A. Length of B. I mean, the length of shape B over length of shape A, if they are similar. I want you to take note of my arrangement. If A is similar to B, that means I can also say if B is similar to A, if B is similar to A, then scale factor equals length of A over length of B. Is that clear?
Yes, sir.
So write that quickly. Then we'll now consider
Yes.
example.
I'm done, sir.
Okay. Let's look at this one. The question says decide whether the two triangles below are similar. So you have this 4 centimeter, 4 centimeter, 6 centimeter. Then you have 6 centimeter, 6 centimeter, 9 centimeter. So these are the two triangles. We are asked to decide whether they are similar or not. So write the question, draw the triangles. Then if you can attempt it based on what you have been taught now, let me know. Are you making progress?
Yeah, that's similar. Asking me, sir, that's similar. Because the scale factor is 1.5.
Okay. The scale factor is 1.5. Okay.
Yes, sir.
You use scale factor to decide that they are similar.
Yes, sir.
Okay. All right. Let's look at it from this perspective. Now, I would love to label this one as A, B, C, triangle, and label the other one as P, Q, R, triangle. Now, if they are similar, then AB ratio PQ should be the same thing as BC ratio QR, should be the same thing as AC ratio PR. Is that clear? If they are similar, let's now check. AB is 4. PQ is 6. BC is 4. QR is 6. AC is 6. PR is 9. So I can reduce 4/6 to be 2/3. 2/3. Then I can reduce 6/9 to 3 here 2, 3 here 3, 2/3. Can you see that?
Yes, sir.
So that's what the first condition is saying, that if they are similar. Do you understand that now? I mean, the
Yes,
second
sir.
condition rather, if they are similar, all the sides of one are in the same ratio as the other. So if you can find ratio of one side that is not the same as the other, then you make your conclusion that the triangles are not similar. So one is sufficient to make that conclusion that they are not similar. Do you get that now?
Yes, sir.
So you can also write this one as alternative. So when you're done, let me know.
I'm done, sir.
Okay. So let's see another question. Example 2. This one says verify whether the triangles below are similar. Here is 5 centimeter. Here is 8 centimeter. 8 centimeter. Then the other one, 6 centimeter, 9 centimeter, 10 centimeter. Verify whether the triangles below are similar. It's a one-word answer.
Excuse me, sir. Your screen is like glitching out.
What is it?
Your screen is like glitching out.
My screen
Yeah.
is like what?
It's like glitching out.
Glitching out.
Yes, sir.
Maybe it's service. Let me relocate my Wi-Fi. How does it appear now?
Yeah, that's better, sir.
Okay. So you have to verify whether these triangles are similar.
Okay. Okay, it's better now.
Okay.
Is the one okay? Don't worry, don't worry. Okay.
So we have 10 minutes left.
They're not similar
Very good. How do you know that?
because when you put like labels on it and you put in like the dividing, it doesn't equal the same thing.
Okay. If you take their ratios.
Yes, sir.
Yes. And yes, It does not satisfy any of the three conditions. It does not satisfy these three sides to give us the same ratio. It does not satisfy angles. The three angles must be the same. It does not satisfy two known side and one included angle either. So all the three conditions failed. That's good. So let's look at this one quickly. Number 3, you have these triangles. Sorry, give me a few minutes. I just want to attend to a call, please.
All right, sir.
Yeah, sorry, please. So you have PQ to be 4, and you have angle P to be 35 degrees. Then you have QR to be 3 meters. So that's shape A. Then you have triangle B. This place is 12 meters. X, Y, Z. And this is 35. So the question now says that draw that and write quickly because we have 7 minutes. Triangles PQR and XYZ are similar. PQR and XYZ are similar. So question A now says, find the scale factor. Find the scale factor that takes you from PQ.
It is scale factor 3.
What do you say?
It is scale factor 3.
Is the scale factor 3? Okay, you have done it already. That's good. Yes. Find the scale factor that takes you from PQR to XYZ. Yes. B says find the length of YZ. Find the length of YZ. So can you do the B part also?
Yes, sir. YZ is 9.
YZ is 9, correct. Correct. So that's good. So I want you to quickly do this one. In 2 minutes, you should be able to do that. Decide whether the triangles below are similar. Decide whether the triangles below are similar. You have this triangle. This side is 7.5. This angle here is 40. This side here is 9 meters. And the second triangle, you have 2.5 meters. You have 3 meters. And you have angle here 40. So decide whether these two triangles are similar.
Wait, does that say 2.5 for the first triangle?
Yes. For the second, no, for the first triangle is 7.5.
That's
This one is
7.5.
7.5. For the second one is 2.5.
Okay, then it's similar then. Because the scale factor, yeah, the scale factor of 1/3. And it has the same angle.
Yes, what do you say again?
It has the scale factor of 1/3 and it has the same angle.
Very good. Very good. Yes, quickly do this one. B. The same question that you should decide whether the triangles are similar. This angle here is 33. This angle here is 52. Then the other triangle, this angle here is 95. This angle here is 33. Are they similar or not? You have less than 2 minutes. So what can we say about that? Hurry up. Should I help you?
No, I'm trying to calculate it.
Okay. So all you need to do is to find the unknown angles in each. We will do that quickly because our time is fast spent. You cut off any moment from now. If you find this angle here, you must get 95. All right? If you find this angle here, you must get 52. So the two triangles are similar because all the three angles are the same. Is that clear?
Yes, sir.
All right. So that's the reason why they are similar. So once you are logged out, of course, you have to relog in again quickly. So that will not
Yes,
take
sir.
the last batch.
Let me just stop a pen to log in again.
So